Oh, hey guys. So I won't be here today, but your notes for today are right here. I forgot to do warm up today, so don't worry about the warm up. Sorry. All right, so we're gonna be talking about slope, kind of an extension of dilation, similar triangles in a sense, but we're going to be looking at lines a lot. So our learning targets and success criteria are: I can learn about the slope of a line by drawing a line on a grid with a given slope and finding the slope of a line on the grid. So vocabulary: slope of a line is just how steep a line is. Steep a line is. Like a mathematical definition of this is going to be the vertical change of a line divided by the horizontal change of a line. It'll typically be a fraction, unless it's a whole number, which is also still a fraction. We'll also call it something called rise over run. Wow, that was an awkward way to phrase that. Anyway, I will refer to slope as both of these things in class, so just realize it means the same thing. If I have like a grid right here, and I have a line that's kind of like going something like this, you can like kind of draw a triangle on your line. That's not a great right triangle. You want to draw a right triangle on your line. You can either do it above if it's a positive line, or below if it's a negative line. Is this focused? Yeah. And it would maybe be something like 1 over 2, so that's your vertical change this way, and your horizontal change this way, so your slope is going to equal 1/2. Mr. Wishart, why did you write an m there for slope? Oh, that's because that's the variable we use for slope. I don't really know why it's an m. It's not an s, because maybe s's look like 5s, or my s's look like 5s anyway, and so I don't know. Maybe the mathematicians from hundreds of years ago were thinking about what my s's look like, and so they're like, oh, we better not make it an s. Well, let's make it an m. Anyway, m is slope. That'll be kind of interchangeable in this class. But yeah, we go up 1, that's your vertical change, and we go right 2, that's your horizontal change. Okay. So as kind of our stepping stone from our previous work into this new work, we have these 3 triangles on the line. I have triangle A, B, C. I'm actually going to grab a highlighter. I have triangle A, B, C, and then I have triangle C, D, E, and I have triangle F, G, H. So the idea here is figuring out which of these triangles are similar to each other, and talking about our reasoning. So if I look at the slope here, it's kind of already like measured out, right? I'm going up 3 and over 4. You can see that they put the triangles underneath it, but I put it above it. If I had made this graphic and not pulled it from the curriculum, I would have made the triangles on top of the line because it's positive, but what are you going to do? So if I look at the slope for ABC, I can see that it's going up 3 and over 4, right? And then if I look at the slope for CDE, I can see that it's going up 6 and then over 1, 2, 3, 4, 5, 6, 7, 8. So let's look at triangle ABC right here. We've got our slope being up 3 and over 4, and then our slope for triangle CDE is up 6 and over 8. And then our slope for this is going to be up 1.5, or 1.5, and over 2. So let's see, FGH is going to be 1.5 over 2. Okay, and we can see that we have a scale factor of 2 of each of them, right? If I start at the small one and I multiply it by 2, right? 1.5 times 2 is 3, and 2 times 2 is 4, right? So, and then I kind of move into the next one, right? 3 times 2 is 6, 4 times 2 is 8, right? So each of the triangles is just getting twice as big, right? And so since we're kind of doing the same scale factor, we can see that they are similar. So they are similar. They're all similar, all 3. Because it's the same scale factor. Same scale factor for each one, right? right? We could also say the sides, let's not say the sides, let's say corresponding sides are proportional. Corresponding sides are proportional. Okay, you can also, like, the same fraction, right? You're just simplifying the fraction as we go, right? So even though the triangles are different sizes, they have the same slope, basically how steep the line is, because, you know, they are all the same fraction, and it's the same scale factor to go from one to the other, okay? Okay. So we're going to find the slope of this line. The trick here is to just find 2 points on the line that are on the corner of the grid, right? Now these are all options for this here. You can use this to this to this to this, right? We can go up 1 over 3, right? We could even go up 2 and over 6, and we could go up 3 and over 9, right? So our slope is going to be that vertical change for each one, and it doesn't really matter whether you do 3/9, 2/6, or 1/3 as your kind of count. Well, those look kind of weird when we split them up like that, because they will all simplify to the same fraction of 1/3. I mean, you definitely should simplify the fraction, but these are, you know, equivalent values right there, right? So it's our vertical change, that up and down frame change, divided by that horizontal change that goes from left to right. Now, when we look at this one, right, we can see that this is positive. Our line is basically going up. If you were thinking about, like, I don't know, if you had a shoe company and you were selling shoes and your profit line was going up rather than down, that would be positive. So this is a positive slope. However, if you take a look at number 3, our lines are going down, right? So if the sales of your shoe company were going down, that would be negative. This is a negative slope. Okay? And we do that same thing here, right? We just find points that are on the line. I've got one right here, not quite right there. Let me actually on this guy. Focus. Yeah. So we got one right here, not here or here or here or here. I have one right there. And then I keep going. It looks like I have one right there. So kind of like 3 possible ones that I can work with, right? I'm just going to use this first one right here. I'm going down 2, and I'm going right 1, 2, 3, 4, 5. Now you'll notice that on the positive line here, I drew my triangles above the line so that my slope would automatically be positive because I'm going up and right. But on a negative line, I will do my triangle on the bottom of the line so that I get a negative here, but on the bottom I'm still getting a positive, right? So I don't want 2 negatives because it will change that into a positive if I'm dividing, but I have this one negative right here that kind of like makes the entire line negative. So that's my negative 2/5. Again, I could go all the way down and go negative 4/10 if I wanted to, and that would be the exact same thing because that's the equivalent fraction right there, okay? For number 4, I kind of have this grid without any numbers on it, right? And all I'm going to do is draw a line with the slope of 1/2. So starting here, I'm just going to go up 1 over 2. Technically, I could be done and just draw the line right here because I really only need 2 points to kind of like just like draw a line. But because I am a human and not a robot yet, I want to kind of like draw all the way across the graph. So I go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And to get more points on the line, I can reverse it. So instead of up 1 and right 2, I can go down 1 and left 2. Down 1 and left 2. You have to reverse both directions. Otherwise, you get you don't get a line. You get kind of like a, I don't know, a sideways V, or like a greater than symbol or less than symbol. And then, you know, use a straight edge, right? Because this is 8th grade and you're 8th graders, and you can definitely do that. You'll notice I'm putting arrows on it because that line goes forever infinitely. And again, we're going up 1 and right 2. So this is a positive slope. Okay, this one's negative, so we're going to go down 5 and right 3, from this point right here, okay? So we have a negative slope here. So we're going to start here. We're going to go down 5, 1, 2, 3, 4, 5, and then we're going to go right 3, 1, 2, 3. You might think because it's negative, you're going to go down 5 and left 3, but you can see that that just makes another positive line, right? You only need the one negative to make the line negative. If you have two negatives, they cancel out, and then it becomes positive. So just be aware of that. That is one mistake that students make all the time, okay? And then to make my line even straighter, I'm going to reverse it. I'm going to go up 5 and left 3. So 1, 2, 3, 4, 5, and then 1, 2, 3 to the left. And you'll notice that it gives me a nice straight line right there, like so. Okay, again, negative slope, it's going down. Now, number 6. So we're going to start at the origin, 0, 0, and we're going to draw a line with a slope of 4/7. So we're going to go up 4 and right 7. Again, this is positive. That's like, remember, you're selling shoes, you're selling more and more shoes, so that's a positive thing, you're making more money. So we're going to go up 4, so 1, 2, 3, 4, and then we're going to go right 7. 1, 2, 3, 4, 5, 6, 7, right there. And I have my point at my origin. I'll actually give myself another point. I'll go down 4 and left 7. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, right there. And I've got my line here. Okay. Now, if you were so inclined, you could write this equation as y is equal to 4/7 x. Okay? Since we're going through the origin, this would be a proportional relationship, which we have talked about before. Okay? Yeah, so this would be unit rate, so 4 whatever per 7 whatever, right? Or 4/7 of something for every one value of x, change you have for x, whatever. It makes it a lot easier when you have labels on your graphs. So forget about that. Okay, so from the origin here, we're going to draw a line with a slope of negative 6/5. Again, it's negative, so it's going to go down. So we're going to start at 0, 0. Then we're going to go down 6. But we're still going to go right 5, right? Even though this one's negative and this one's positive, you're still going right for the bottom number, okay? Again, that reason is if you have two negatives, it would make it positive, and since this is a negative slope, you don't want that, okay? Let me zoom in on this one. Starting at the origin, we're going to go down 6 and right 5, so 1, 2, 3, 4, 5, 6, and then down right 5. 1, 2, 3, 4, 5, right there. And then from the origin, we'll actually reverse it again to give ourselves another point, so our line will be even straighter when we draw it. So up 1, 2, 3, 4, 5, 6, and then left 5 instead of right. 1, 2, 3, 4, 5. Okay, it is useful to get in the habit of drawing as many lines across the graph as you can, because your lines will be straighter, and sometimes a positive slope will send you off the graph if like your origin point is like really close to the top of the graph. And sometimes you'll have a negative slope and your origin point will be way down at the bottom of the graph and it would send you off the graph. So you need to be able to reverse your pattern to get back onto the graph. So it is useful in that sense to be able to recognize that's what's happening. If we were to put an equation together for this, it would be y equals negative 6/5 x. Since it is going through the origin, again, this is proportional. Okay. Thank you very much. Oh! Just so we're clear here, we're going to be putting this in our binder. Okay. So, table of contents, this is going to be number 8. In your table of contents. What did I call this? I called this lesson 10 through 12, Introduction to Slope. This is going to be number 8. We'll say notes, lesson 10 through 12, or lessons 10 through 12, I suppose. Introduction to Slope. I will zoom out fully on this page. Even more zoomed out so we can get everything. Maybe. All right, there we go. If you want to pause right there and fill out your table of contents, go for it. But from this point on, I'm going to kind of show you what's in the order of this again. All right, we have dilations. We have skills mastery is our first one here. That's where you should be getting. You should actually, honestly, have a lot of stickers here. Then you're going to have lessons 4 through 5, right? Then you're going to have your dilations reference sheet. Then this was a video that I did that I posted, but we didn't actually do it in class. Then your pretest / test review. Okay. Then you have lessons 6 through 8, similarity and similar polygons. Then we have lesson 9, side lengths and similar triangles. Then we have dilations and similarity practice. And then the brand newest thing that we did here, you've got lesson 10 through 12, introduction to slope. Put that in there, and then work on your practice sheet. And once you're done with your practice sheet that relates to slope, you can go to your test review right here. I would love it. Oh shoot, honestly, at this point, you could probably do number 1. You could work on number 2. You could work on number 3. You could do a little bit of number 4, honestly. Shoot, at this point, we've done some of that. I mean, honestly, after what we just did, you could probably do number 5. You might be able to do number 6. We haven't done number 7. No, don't worry about number 8. You could definitely do number 9. You could do number 10. Maybe you could do number 11. Actually, maybe you could do number 11. I don't know. But anyway, after your notes, which you should have just finished, and your practice page, you can work on your pre-test / test review. So yeah, there you go, guys.